Hello guys, this is a continuation of the previous video. In the previous video, I told you about Fibonacci series and how we are going to calculate Fibonacci series using recursion. Now, to rubber stamp this particular concept of recursion, I'm going to explain to you how factorial works using recursion. Now, this is very interesting. I'm sure if you Google recursion, this is the program that everybody would be talking to you about. It's a very popular program to explain the concept of recursion, and I'm very sure you have already understood the concept of recursion by now, but this program will make sure that you understand it even better. So let me uncomment all this. Okay. So what happens when you use multi-line comments is that, for example, if you comment from this particular place to this particular place, then this whole thing becomes comments. The compiler just will ignore the comments. Comments are just used for users' readability. And the reason I've commented is because this particular function and this particular program should not interfere with that particular program. So whenever I execute a particular program, I make sure I comment out the previous programs. So let's calculate the factorial using recursion. So as usual, it starts from the main function, and then the user has to enter a number, and then the user enters a number, and the factorial is it goes to this particular function right here. And then it says int my factorial and then the number. If the number is 0 or 1, you basically return that number. Otherwise, you return that number times factorial n minus 1. Okay, now let me explain what happens here. These are the sequence of operations that happen. For example, if the user enters the number 5. Now we all know 5 factorial is 120. So how did that come about? N into n minus 1 factorial. So 5 into 4 factorial. That is how we got 120. The same thing happens over here. Now if the user enters 5, it will first check if number is equal to 5 is equal to 0. No. 5 is equal to 1. No. Then it goes to the else part, and then it basically becomes 5 times, and then we comment this out, 5 times my factorial n minus 1. This becomes 4. Do we know the value of my factorial 4? We don't. So the next becomes 4 times my factorial of 3. Then the next one becomes 3 times my factorial of 2. And then the next one becomes 2 times my factorial of 1. So we do know that if n is equal to 0 or 1, we basically return n. So since we know the factorial of 1 is 1, this becomes 2 times 1. The value of my factorial of 1 is 2. Because we know that if n is equal to 1, we basically return n, which in this case we return 1. And then this becomes 3 into my factorial of 2, which is 3 times 2 equal to 6. So that's how 3 factorial became 6. And then 4 factorial becomes 4 times my factorial of 3. So 4 times the 6 will give us 24. And then 5 times my factorial of 4 will become 5 times 24. And this becomes 120. So this is how factorial works in recursion. It's very simple. It's very similar to the program where we saw the sum of n numbers, and that was calculated in the same way. Only thing, you have to put a multiplication symbol over here, and this is how factorial is calculated. So for example, if the user had entered 3, it will become 3 times factorial 2, and then it will become 2 times factorial 1. And then you do know the value of factorial 1, which is 2, and then 3 times factorial 2, which is 3 times 2 equal to 6. So this is exactly how factorial is calculated using recursion. In the next example, I will tell you how GCD is calculated using recursion. Until then, see you.